All right, class. Yes, good evening. So, Khalid, Salman, Sumaira, Sneha, and Zaid are here. Fine. In the last class, we had completed Ampere circuit law. The whole topic got completed. There we had discussed solenoid was there, toroid was there, and the formula of solenoid and toroid was same. It's just that in case of toroid was in a circular form. So n divided by 2 pi r was there, where the number of turns per unit length could be represented as small n. In case of solenoid, we had discussed V is equal to again mu naught Ni. N was number of turns per unit length. So length you have to keep it in mind. And what is Ampere circuit law, basic law that we were discussing. We had continued it in the last class. Now this is a new topic, magnetic Lorentz force. This gives you the direction or basically the path of the charge in the magnetic field. This helps us in getting the path of the charge in magnetic field. What is the path of the charge? Now here we'll be using the directions to calculate the path, to check it. Sometimes it happens that the path goes into a complete circle. That question is very common, and that topic is also very common. So that we'll discuss. But first, let us discuss what is the magnitude or how to calculate this magnetic Lorentz force. Let's take let's say these are the magnetic field lines. B I have taken. Fine. And there is this charge. This is the charge plus Q that I have taken, and it is moving with some velocity V, making an angle of theta with the magnetic line. All right, magnetic field, the angle between magnetic field lines and the velocity is taken as theta. I'll write that also. So it says, basically this says that charge Q, this is moving with velocity. What's the velocity I've taken? V. V in a uniform magnetic field. In a uniform magnetic field. Now, magnetic Lorentz force will give you the direction, will give you the magnitude. Since it's a force, obviously we'll have to calculate the direction of it. Now, first magnetic field. Let's just see what is the formula for it. Magnetic field on the charged particle or exerts a magnetic force. This exerts a magnetic force. That magnitude of that magnetic force, this is given by, see, let's represent it through FB. This is the magnetic force. That's why I put in this B in the subscript so that you're able to understand. This is basically given by the magnitude of the charged particle, and take the cross product of magnetic field and the velocity. So remember, whenever, as we have discussed earlier also, in case of cross products, we never change the signs. Like if it is I cross J will give you K cap. If it is J cross I, that gives you minus K cap. So you cannot reverse it. Like in case of dot product, you can write the first one, second one later on. That doesn't affect your answer. But in case of cross products, you have to keep it in mind. So this becomes V cross V. And how do we open this? V cross V is there, and theta is also mentioned. So which function of trigonometry should come? Sine of it, cosine of it. How to open this? Cross product, basic cross product. Nobody remembers. Yes. Yes.
Sine theta.
Sine theta. See, FB will be equal to, this will be equal to sine theta. In case of dot product, see, whenever you do dot product, in case of dot product, it occurs, cos theta occurs in your answers. But whenever you are discussing this cross product, in case of cross product, like we did PE sine theta, E cross E was there in calculation of torque when dipole was given. Similarly, this FB will be equal to what? Q VB sine theta. Now, when we open it, no, this cross product, then we write it as the magnitude of V, and then we change it. That doesn't fit. But when it is V cross B, because at times it can happen that velocity will be given in terms of I cap, J cap, Cartesian form. Magnetic field is also given in terms of Cartesian form. There, when you have Cartesian form, you have to put in the whole determinants to solve it. The whole determinants portion, then you write I cap whenever you're doing cross product. If anyone is having issues with cross product, don't worry, we can take a class on cross product and dot product as well. But right now, so that's why you have to keep it in mind, whether it's V cross V or B cross V. Similarly, in case of Biot-Savart law, whether it was DL cross R cross DL, all these things. The way in torque also, it is R cross F. We never write it as F cross F. So similarly, here also this is VQ, VB sine theta. And theta is basically angle between velocity and the magnetic field. Everything depends on it. Let's say if this is the magnetic field and this is the motion of the charge. Angle between both are parallel. This is 0. So sine 0 becomes what? Sine 0 becomes 0. So your FB will also come out to be 0. Remember, whatever sign you are taking, even if the angle is mentioned with something else, you have to take in the angle between velocity and the magnetic field. First, note down these points, then we'll see it in detail. See, if your force is perpendicular this to velocity, if it is perpendicular to velocity, can anyone tell me what will be the direction, what will be the angle between force and displacement if force is perpendicular to velocity? See, what's the relation between velocity and displacement? With that, can you relate? What will be the angle between force and displacement if force is perpendicular to velocity? Anyone? See, if velocity and the direction between the force and velocity, this is perpendicular, then obviously the angle between force and displacement will also be perpendicular. Means the angle will be 90 degree. If force is perpendicular to velocity, it should also be perpendicular to, it should also be perpendicular to displacement. So basically what happens? This becomes perpendicular to displacement. So if your F is perpendicular to V, then your Vf also becomes perpendicular to displacement. Now can you tell me if force and displacement are perpendicular to each other? If force and displacement, both of them are perpendicular to each other, what will be the value of work done? Force and displacement related with work done. Yes, Salman, answer. If force and displacement are perpendicular to each other. No idea, Salman. Khalid?
FS cos 90.
Yes, F is cos 90. See, work done's formula from your earlier classes, you must have done this. This is F dot S. That becomes Fs cos theta. Here theta is 90 degree. Cos 90 becomes 0. So here also, if it is work done is Fs 90 degree, this will be 0. And if such a condition occurs, then your initial kinetic energy will be equal to the final kinetic energy. How? You remember, if you're able to recall, you must have done work energy theorem. Work energy theorem. In work energy theorem, basically it said that all the work done is equal to the change in kinetic energy. These are some additional points that are required for your theory questions. Numericals do not come from this. Usually the numericals do not come from this. If the numerical comes, you can put in the values. Otherwise, theoretical questions come. What happens to the work done if the force is perpendicular to velocity, and all these questions directly come. So this is what the kinetic energy final minus kinetic energy initial. So if work done becomes 0 as force is perpendicular to displacement, then your final kinetic energy becomes equal to the initial kinetic energy. So theoretical questions can come in this way. What happens to kinetic energy if force becomes perpendicular to velocity according to magnetic Lorentz force? So you can answer there won't be change any in the kinetic energy. If there is no change in the kinetic energy, let's say half V1 V final square was equal to half m V initial square. So we can say initial velocity equals to the final velocity. So there is neither change in kinetic energy, and so there is no change in your final velocity as well. So these theoretical questions can also come. Apart from this, we have the direction. But before the direction, okay, let me tell you the direction. See how to, again, we'll be using right hand thumb rule only. Right hand thumb rule. Right hand thumb. Let's take magnetic field lines are there. A charge is kept. Let's take random velocity. Let's say this is the velocity direction. This is B, this must be making angle. Right now we are not concerned with the angle. Why? Because magnitude we have discussed. We are calculating what we are just focusing on how to take the how to take out the direction. See, keep your fingers of your right hand, use your right hand. So keep your fingers along the velocity, direction of velocity. If your velocity is downwards, then place your hand downwards. If it is upwards, place it upwards. So this is my right hand. If I put it in the direction of velocity, this will occur. It will occur like this. And then curl it towards the magnetic field. If you curl it towards the magnetic field, this is the velocity according to me. Just try it at your home also. Right now also do along with me. This is your velocity, curling it towards magnetic field. By magnetic field is in the right hand side. So I have to, if I place it like this will also be when my hand is placed along with velocity. But curling in this direction is not possible. I have to curl it in this direction in the magnetic field. So if I curl it like this, then the thumb gives the direction of what? Thumb gives the direction of force. So if this is kept like this is, so force will be like this. This is velocity, this is magnetic. Into the plates. No? Just try. This is velocity, this is magnetic. Into the plates. Yes. This will go inwards. Understood this? Just do it along, then only you will be able to understand. Let's take one more example. These are the magnetic field lines. A random example I'm taking. This is the charge. This is the direction of velocity. All of you, write me in the chat box quickly. What will be the direction of force? This is the direction of magnetic force. Velocity towards the magnetic field, inwards it led to. Just try it for this part, second part. And answer me right now in the chat box. Okay, Khalid. Samira, right? Zaid, Sneha. Who else is there? Zaid, Sneha, and Salman. Zaid has answered. Good. See, to all those who are not able to understand it. If I keep my hand again like this, all right, then my hands, the fingers or the edges means basically the nails. These are pointing upwards. But is the velocity right now in this way? Velocity is like this right now. This is the direction of velocity right now. Like this, you can see. Downwards, not exactly downwards will be this, basically slightly towards the left hand side, but pointing downwards like this. And then curl along the magnetic field. Thumb is where? Thumb is going towards me. That is out of the screen. So that becomes what? Here it becomes, force becomes outwards. For this charge, force becomes outwards. This is the direction of force. First, tell me, is this clear to all of you, or should I repeat it once, the direction? Salman, Sneha, clear?
It's fine, ma'am. Yeah, it's fine.
And what about you, Sneha? Understood it? I'll repeat. See. But Sneha, for understanding, you have to do it along. Wherever you are studying right now, just do it along. Then only you'll be able to understand. First, just look at the first one. First means this one. This is the first one. This is the second. Now, keep your fingers, your hand in the direction of velocity. Velocity is like this. Just see the velocity and see my hand. Both are like this. Now I have to curl it towards the magnetic field. Magnetic field is where? Magnetic field is like this, means in the right hand side. So how will I curl it like this? I cannot curl my fingers like this. Now if I shift it like this, curling fingers is towards the left hand side. I cannot. If I keep it like this, curling fingers is towards me, magnetic field is not pointing towards me, magnetic field is pointing towards the right. If I keep it like this, now it is pointing towards the right. So magnetic velocity, along the velocity, keep your fingers, curl it towards the magnetic field. Where is the thumb leading? That gives you the direction of magnetic force. I'll write down also the rule, right hand thumb rule for it, but understand first. Sneha, is the first part clear? First tell me yes or no. Then second part we'll discuss. First part is clear. Second part velocity is pointing like this. Earlier it was like this, now it is like this. All right, so if I keep my hand like this, in this way, here curling? No, not again. The magnetic field is not here. Magnetic field, if I place it like this, and if I curl it in this way, then see, magnetic field is basically in this direction. So if I am curling it here, thumb is pointing out of the screen. Out of the screen means out of the page, that is outwards. Now clear, Sneha? I'll write it also. We'll do more questions, then you will be able to understand, because one huge concept of calculation of radius, calculation of time period frequencies with the help of this right and thumb rule only. So in this today's class also we'll discuss it. So it says that place your fingers along velocity. This is the first step. Curl your fingers towards magnetic field, direction of thumb gives direction of magnetic force, which we are supposed to calculate. This is given by right hand thumb. Before you note down this part, no, two things I'll do that are very easy. Then one thing that takes time, and that's a huge topic. I'll discuss it afterwards once you have written this portion. So first, these two topics, basically the path of the charge in magnetic field. In uniform magnetic field, I'll write down also path of charge in uniform magnetic field. Basically in uniform magnetic field, this is the path of the charge. So case 1 occurs if the particle is moving parallel to magnetic field. If the particle, what particle? Charge particle. So if particle is moving parallel to magnetic field. All right. Now from Lorentz force, magnetic Lorentz force, you can calculate. F was what? F was QVB sine theta. QVB sine theta. Theta here will be 0 degree because particle is moving parallel to magnetic field. If this is magnetic field, then your charge is also moving like this. This is what is meant by the first case that we have discussed in short also earlier. So it means force will be 0. This says that the path will not change. So remember, these small little points come in your theoretical papers and even in your competitive exams after your class 12th also. These small questions, that if particle is moving parallel to magnetic field, then what happens to the path of the charged particle? What will you do? This is the reason to it. And the conclusion is that path will not change. All right, path will not change. Similarly, had it been anti-parallel, second case says that if it is anti-parallel. So if this is anti-parallel, then again you can say FB will be what? QVB sine 180. Sine 180 is also 0. So it's like these are the magnetic field lines. This is the charge. This is the velocity, means opposite, making an angle of 180 degree. So again, path will not change. But now we'll see the third case that is very important, that we'll see once you have written this question. That will take a lot of time. So first note down all these points. Wherever you're not able to understand, ask. From which part you have to write? From here, no? So here the concepts of uniform circular motion will be used. So we'll discuss also that in brief. Uniform circular motion, that was done in your class 11. Now why that will be used? See, if your third case, two cases we have seen, parallel, anti-parallel, force is zero, path won't change. This is the case if your magnetic field and the particle both are perpendicular. If particle is perpendicular to magnetic. All right, so let me draw perpendicular magnetic field. This is pointing inwards into the page. So magnetic field is where magnetic field inside is inside, and your charge is here. So both are perpendicular. Charge is kept like this, and magnetic field is inside. So your charge is here. Let's say, sorry. This is your charge, and your velocity is this. This is velocity. Now, all of you quickly, all of you tell me the direction of magnetic Lorentz force. Magnetic field is inside, velocity is in the right hand side. Where will be the direction of force? Whoever is forgetting, check it in your notes. Magnetic field is inwards. These cross symbolizes inwards.
Ma'am, we have to the direction of force.
Yes, force. Keep your hand towards the velocity, curl towards the magnetic field. See where your thumb is leading. Upwards, downwards, inwards, outwards, right, left. Whatever you are getting, just write it in the chat box quickly. So your thumb is going in the same direction as that of magnetic field. You have to curl your fingers towards magnetic field. See where the thumb is pointing. Place your hand along the velocity. See how will you place it if you have to curl it. When your magnetic field was pointing towards right, you have to keep your hand like this. You had to keep it like this. If it is inwards, how you have to keep your hands? Just see. What about others? Yes, Salman, Khalid, both have the same answer. Shamaira, Sneha, Zaid, your answers? Okay, Sneha is not here. Zaid and Shamaira. No idea. Shamaira? Oh, yes, Shamaira. See, when you keep your hand like this is in the direction of velocity. This is the direction of velocity. Curling inwards. Thumb is pointing upwards. How you people are getting it inwards or outwards? Inwards means along magnetic field. How are you curling that you're getting? Are you keeping your hand like this? You have to keep your hand like this in the direction of velocity. Curl inwards because magnetic field is inwards. Force is upwards. So here the force will be where? The force will be upwards. You will be having the force upwards. How did we do it? Velocity curling towards the magnetic field, force is upwards like this. This is how we calculate it. Another case I'm giving. Nobody answered this part correctly. Now this is the direction of velocity. Now tell me what will be the direction of force. At least try this part now. Earlier in the first part, what did we do? This is the direction of velocity. Curling inwards towards the magnetic field. Upwards gave us the direction of. This will be what? Quickly. This time you also try, Zaid. Yes, Salman is right. Salman is right. It will be left, not down, Zaid. See, velocity is like this now. I have to curl it inwards. Force, thumb is where? Thumb is pointing to the left hand side. So direction of force will be where? This will be the direction of force towards the left. Okay, clear. Fine. Now tell for this charge particle with velocity. And then tell it for this charge particle. First, tell me for this one. Yes, now it will be downwards. Said Sumaira. Good, good. It will be downwards. Who else answered? Khalid and Salman. See, keeping towards the velocity like this, curling inwards towards the magnetic field. Thumb is pointing downwards. And what about the last part? You should be quicker when you reach this last part. This will be right. Definitely. Yes, Neha, Salman, good. This will be towards the right. Velocity will be like this. You have to keep your hand, curl it. This is the direction of thumb. So you have it. Now see, why did we do all the parts? So why did we solve all the parts? Because this has a significance. Now you will be able to understand. The path has covered what kind of motion? If all the particles, let's talk about, let's say this was a single charge particle. This was here, it went here, it went here, it went here. This was actually in the form of a circle that we are doing. This direction you have understood with the help of right hand thumb rule. See, if the magnetic field is pointing inwards like this, then your motion of charge particle is in the form of circle. I'll draw it. Your charge particle is in the form of a circle. Now, when the charge particle was in the form of a circle, what happened to the force? All the force pointed in the center. Can anyone name from your previous knowledge what is this force that we got? Definitely Lorentz force, magnetic force we are calculating. But another type of force that comes when circular motion is involved. Charge was moving like this with velocity. Anyone, can you name this force that is towards the center? Have you heard of the term centripetal force? You must have done it earlier in your classes, class 11. Centripetal force, yes. See, let's just quickly revise your circular motion. Otherwise, you won't be able to relate it to it. So when you have circular motion, centripetal force is occurring, charge was moving with a particular velocity, and let's say this is the radius of the circle. In the centripetal force, the magnitude of centripetal force, this is given by mv squared divided by r. M is the mass of the particle, v is the velocity, r is the radius. Radius means from the center this distance. M, remember, this is the mass of the particle. V is the velocity, r is the radius. Similarly, you have one more term, omega, which is written by v divided by r. So this concept will be used here. This is mv squared divided by r. Now we have to relate it with Lorentz force. Again, we actually calculated a Lorentz force. That was what? Fv is equal to Q VB, this time sine 90 degree will be there. Why? We took the case when charge was perpendicular to magnetic field. So this becomes QVB. And centripetal force will be mv square divided by r. Actually, FB is equal to FC because both are same. So we can equate it. This becomes mv square divided by r is equal to QVB. 1v cancels. What's the value of radius that we are getting? Radius will be mv divided by q. This will be the formula of the radius of the circular path. You will be getting numericals. We'll do a numerical also. This radius of circular path. So basically this relates with your laws of motion, circular motion, uniform circular motion, where you have all the details about angular acceleration, motion in a vertical circle, all these topics. So basically this formula you have to remember, mv square divided by r, and this will be used. This formula is very common, so all of you should remember. Those who have forgotten it, remember it right now. Centripetal force is given by mv square divided by r, and direction is along the radius towards the center of centripetal force. That you must have done at your earlier classes. If anybody wants, I will write it down also. The direction of centripetal force that is given by along the radius towards the center. Centripetal force. Centrifugal force points outwards, opposite to it, but centripetal force is along the radius pointing towards the center. From here, you can calculate one more thing. See, time period will be given by what? Distance divided by speed is distance divided by time, no? So time will be equal to distance divided by speed. So distance is 2 pi r divided by speed. Speed is this. So let's write down the value of speed from this equation. Speed will be what? QRB divided by m. Yes, QRB divided by m. So this becomes 2 pi r. Let's put in the value of velocity. Q, B, R, and M will go in the top. So R gets cancelled. Formula of time period becomes what? 2 pi M divided by Q, B. This is the formula of time. Frequency, can anyone tell by just looking at it?
QB by
2 by m.
Yeah, that's it.
And QB divided by 2 pi m.
QB divided by 2 pi m. Because time period is inversely proportional to frequency, and this relation we did when we were discussing current electricity. Remember, we did a question where frequency was given and current was asked to calculate. So it came out to be NE into frequency because of this relation only. So frequency is basically inverse of time period. So this will be QB divided by 2 pi m. All right, one more relation I made you write right now. That was what? Omega. Angular velocity. Omega is known as angular velocity. So angular velocity is basically V by R. Omega. This is what? This is angular velocity. This is an interesting topic, at least from the previous topics that were monotonous, becoming monotonous. So this is at least a bit interesting from that. V divided by R, because the questions are easy. If you remember these formula, no, these questions are very easy, especially for students who are going to appear for their JEE or NEET exams. This question, and especially that kinetic energy one that I'll tell you right now, questions comes a lot from this. So V is what? QRB divided by M. R is this. RR gets cancelled. Omega will be QB divided by M. What is left? Kinetic energy, let's do. Yes, kinetic energy is also important from all points of view. For students who are going to appear for NEET, especially this kinetic energy question, if you take out the previous year question of magnetics and see this question, kinetic energy, directly formula is asked first. Directly the formula, Q square, B square, R square, this way. So these are very important topic and these are easy to score. Even for your board exam, directly values will be given, just put in the values. Because the derivation and all that portion has already been discussed. So you don't have to apply your brain that time. These results you have to just put in the values. So kinetic energy is what? Kinetic energy is written as half mv square. V is what? Q R B by M, no? So that becomes Q square R square B square divided by M square. 1m cancels. Kinetic energy is given by Q square R square B square divided by 2m. See, for your competitive exams like JEE, like NEET, all these exams, even KVPY for students who are appearing and who know about it, or in all these exams, this directly comes, or it can give you slight values to calculate. In your board exams, for your class 12th board examination, CBSE board exams, or the board exams that you have, even your ICSE or other board exams, their kinetic energy to calculate this means you have to show all these steps. So from where you have to start? You have to start from here. Basically depends on the marks. If it's a 3 marker, you have to start from here. If it's a 1 marker, directly write it till here. These 2 lines are enough. But if it's a 3 marker, draw these, means show the steps, show it as a circle. No need to draw the every time take out the right hand thumb rule, because ultimately it will be a circle and everything will be pointing out at the center. So because we did this, so we knew that all the forces are pointing towards the center, so it's a centripetal force. Just write this part, take out radius, not take out radius, take out velocity from here. Show that you are taking velocity using centripetal force, otherwise you will lose marks in your 12th exam. Board exams I'm talking about. Entrances are MCQ, so no need to worry about MCQs you people can handle if you remember the final formula. For your derivations, you have to show that you are taking velocity from this QB divided by M, QRB divided by M from here, and then write down whatever is asked, either kinetic energy, time period, whatever is. A time period is also frequently asked, and this question also comes in your NEET previous year, especially. This question is there: how is time period dependent on the radius? So basically, time period is independent of the radius. Radius gets cancelled, and time period becomes independent of it. So these kind of questions have repeated a lot. So that's why this is an interesting, easy scoring topic. You people will be able to handle it. So this becomes the formula of kinetic energy. Let's do a question also. It will get clearer. If same kinetic energy is given, that questions come in everywhere. This question is very common. Even in your reference books, in your previous year papers, same potential is given, same kinetic energy is given, ratio of all these. We will do a question right now, but first note it down. So third part you have to do, note it down. We'll do that question. That's a very important question that we are going to do right now. For that, understand till here. Wherever you're not able to understand, ask me. Get your doubts clear till here part, this part, then you will be able to do the numerical as well. Numerical is interesting of this part because most of the things get cancelled and calculations are not there. Wherever you are safe away from the calculation, no, the topic automatically becomes easier because most of the chances are there in calculations we commit errors. So in these kinds of topics, you are safe. See, as this perpendicularly word gets mentioned, quickly understand that all these formula are valid. So no need to derive it every time. You can use them directly. But if in the question only the formulas are asked, then you have to derive it. Otherwise, directly use in such kind of question. These questions are very common. Electron can also be given instead of this. So a proton, a deuteron, and an alpha particle enters in a uniform magnetic field perpendicularly. We can use all the formula for radius, velocity, kinetic energy, time period, and all of it. It says you have to find out the ratio of radius, time period, and frequency. Radius, using that formula, time period also reciprocated, that will give you velocity. But the condition is that velocity is the same for the first part. In the second part, momentum becomes the same. In the third part, you have the same kinetic energy. In the fourth part, you have the same potential difference. But for those who are not aware, if mass of proton is mp and the charge on the proton is E, this is for proton, because without this you won't be able to do. For a deuteron, mass becomes 2 times that of proton. Then only it will get cancelled if they are in the same unit. And charge is same. Charge on a deuteron is same. And then what is another particle? Alpha. Alpha particle is there. Mass is 4 times the mass of proton, and the charge is basically double that of the electron or proton. Remember, this data is not a part of question. This I have told you. So it means you have to remember all these. Most of the time in questions only these are used. Where mass is not involved, electron can also be given. So electron, you can use it as. This data you have to remember. See, this is not a part of question. This is, I have told you this so that you can easily solve the question and try it once. Otherwise, this is not given. Take 2 minutes, write down the question, try the first part at least. Any answers coming? Should I discuss it? Let's discuss it. I haven't received any answer from any of you. All right. Same velocity means velocity of proton, velocity of deuteron, and velocity of the alpha particle is same. So in the formula of radius, see these data you have to keep in mind. So what was the first part? Same velocity. Same velocity was the first one. So velocity of the proton is equal to velocity of the deuteron, which is equal to velocity of the alpha particle. Now, ratio of the radius. If I talk about radius of proton is to radius of deuteron is to radius of the alpha particle. I'm calculating this ratio. What was the formula that we had just calculated? mv divided by qb. So m of proton into charge on proton divided mv by q. No. So this becomes velocity. So velocity is same. I'm writing all these as v. So mv divided by, okay, let us just write initially at vp. mv divided by q and b. Magnetic field will obviously be the same because the particles are entering in the same magnetic field S2. Then mdvd divided by qdb is to m alpha v alpha divided by q alpha and b. See what will be the ratio. Mass of proton, let's write it as mp, velocity v, charge on the proton is e, magnetic field is b. Mass on the deuteron is 2 times the mass of proton, velocity is v, charge is e, and the magnetic field is b. Mass on alpha is 4 times mass of proton, velocity will be v, charge on of alpha particle is 2 times e, and magnetic field. You can see velocity will get cancelled, mp will get cancelled, eb from here will be cancelled. So 2 can also get divided. So what is left? 1 is to 2 is to 2. That is the ratio of the radius. So Rp is to Rd is to R alpha is basically 1 is to 2 is to 2. This is the formula of the radius. Fine. So if the velocity is same, this is how you have to calculate mass into velocity divided by qb. So in the formula, you have to just put in the values. Like if it is radius, so put in the formula of radius. If you have it for time period, so time period's formula we did it 2 pi m divided by qb. That was the formula of time period. So there you have to keep it. Let's do for the time period as well. This is how you have to solve these kinds of questions. So time period of proton is to time period is of neutron is to time period of alpha particle. This becomes what? 2 pi mp. The formula is 2 pi m divided by qb. This was the formula. So for proton, it becomes 2 pi mp. Charge is E, magnetic field is B. Samaira, can you tell what will be the formula for neutron? Formula of time period for neutron.
It's 2 pi into 2 mp by EB.
Yes, correct. 2 pi into 2 mp divided by EB. Why 2 mp? Because it is twice the mass of proton. Sneha, can you try for the alpha one? Everything is mentioned to you in your answer sheet only, means in your notebook. Sneha?
4 mp by 2e.
4 mp by
2e.
2e. See, mass will be 4 mp, charge will be 2 mp, but rest of the things will also be there. No, 2 pi will be there. Instead of m, I will write it as m, 4 mp the way you are mentioning, and instead of charge, I'll be writing it as 2e. And then, Fine. So all the things you have to mention. So 2 pi gets cancelled. MP gets cancelled. Same answer we are getting. See? 2. So this also become 1:2:2. And frequency will be what? Just reciprocate it. 1:1/2:1/2. Or else what you can do, you can put in the proper formula for it. You can put in the proper formula for frequency. The answer will be the same. See, you will just have to reciprocate it. Second part was what? Momentum or potential. Same momentum. So see, momentum's formula. Can anyone tell what's the formula of momentum? Momentum's formula. You people have not studied in your class 11th. Momentum. Mass into velocity. That's the formula of momentum. So in the formula of radius, when we are putting all these, m into v is same right now. MP, we used to write it, no? MP, MD, M alpha. Here it is saying M is also same. So the whole numerator becomes the same and the denominator will be the different. So MV divided by EB, this will be the same. And it will be MV divided by, for alpha it is 2 times E. What is left? 1:1:1/2. This becomes the formula. You can do one thing also. You can take the LCM as 2 and means multiply everything by 2. So you will get 2:2:1 also. That formula that is also valid. Similarly, put this in time period. For time period, what will we get? Time period is 2 pi m. What was same here? Momentum was same. So multiply and divided by velocity. But if you multiply and divide the term by velocity, you get it for the time period, because velocity is not given in the formula. So, or you can do one thing directly from the formula. Also, you can put it 2 pi r, but that time you'll be having the radius. No, put it from here only. 2 pi m divided by EP. From the first part, you have the relation between velocity. So you can calculate the time period that manner and reciprocate it for frequency. Similarly, if you have kinetic energy says what? It says half mv square. So again, half mv square is not mentioned nowhere. Like it was given in the third part to calculate. It says that same kinetic energy is given. No. So half mv square is given nowhere. So what you can do, mv divided by qb is there. Kinetic energy is what? You can use that formula also of kinetic energy, but it's better if you write the whole thing from here also. Formula of kinetic energy is q square r square b square divided by 2m. From here also you can calculate the value of radius. So radius value will be 2m into kinetic energy divided by qb. This will be under root, because these under root will get cancelled. Q square b square will get cancelled. So this will be the formula. So what is same? Same is kinetic energy. Again, you can put in the value of under root m and solve. You will get the answer in root, I believe. See, if I put it as Rp is to Rd is to R alpha, under root will get cancelled, 2 will get cancelled, kinetic energy will get cancelled, magnetic field will get cancelled. M root m p divided by E. 2 mp divided by E is to 4 mp divided by. These will be left, rest of the things will be cancelled. Again, root mp by E will be cancelled. 1:2, root 2:2. This will be the value of the radius. Similarly, put in the value of time period from here and put in, just reciprocate it for frequency. And the last part was momentum we have discussed. Kinetic energy done, velocity done. What is the potential? Potential is done. See, potential, we have not discussed it right now because that comes in your second half. Second half means your part 2 of NCERT. So you can leave that also, but let me tell you, there's a formula of kinetic energy. If you have studied well in your chemistry, then you must be having a chapter, structure of atom, I believe. There it includes this quantum physics as well. So a portion of quantum physics is included in your chemistry class 11. I don't know who all have studied it well and have remembered it, but there is a relation. We'll do it again. And we have atoms, we have the whole modern physics, we have everything getting repeated in the second term. All the second term is filled with this only. But right now, remember, kinetic energy is also given by charge multiplied by the potential. So in this radius only, you can put the formula as 2m qv. V is not the velocity, V is the potential, divided by qb. This is the fourth part. Same potential. So see, rest of the thing will be the same again. Charge. What will be left now? Root 2m. All these things will be cancelled. This was r p is to r d is to r alpha. So see what all things will get cancelled. B, magnetic field will get cancelled. Root V will get cancelled because potential is the same. So root V will also get cancelled from here. M will be there, mass will be there. M will be there. And then charge can be written as, if you multiply, that is root Q divided by Q. That will be left. Root Q divided by Q will be left. Magnetic field will get cancelled and potential. Only this will be left, right? Just check once. Root 2. If there anything that can be left, just let me know. This will be left only. Magnetic field will also get cancelled. Potential will also get cancelled. So this much will be left. So you can calculate it from here. So this becomes MP. So M root Q. Instead of writing it as Q, you can write it as E directly. So it becomes what? MP root E divided by E, or you can even rationalize by multiplying and dividing it by this value. Or because root E will be 1 here and root V will come in the denominator. Root M is also there, no? So it's better if we write and rationalize it. Rationalizing means root E and root E here. So this becomes E and EE gets cancelled. So you are left with under root M divided by the charge. Understood this? What did we do? See, rest of the things will get cancelled. Same potential is there. V will get cancelled. B will get cancelled. Root 2 will be cancelled. This was left. So if you multiply and divide it by root E, you get only root E in the denominator. So this can be written. So this becomes what? MP by E. Root will also get cancelled. Now root can get cancelled, no? Because root is common for all of them. This is what, again, this becomes MP by E is to, second result, deuteron. 2 MP by E is to 4 MP by 2. So E getting cancelled. Here we have 2. 1 is to 2 is to 2. You can write it in this way. This becomes 1 is to 2 is to, or you can even write it as root 2 as well. If you do not rationalize it, root 2 will be left. All right. And then again for time period. So method remains the same. Since different types of quantities were mentioned, physical quantities were mentioned, that's why we discussed it. Otherwise, see, in short, whatever are the formulas given to you, if it is perpendicular, all of them are valid, everything gets cancelled. Few things remain the same which you have to relate, and basically try to get mass and charge retained in your answers, because only that will get cancelled. Rest of the things will get deleted. Right? So note it down, try all the parts yourself. Wherever you're not able to understand, then look it on the screen and then solve. Question, you people have written it down? From here you have to make it. And I think for this, from the second part onwards, I haven't done the time period one. So do that also. And what about the assignments? Only Samira has submitted. Yes, Samira, you have submitted the assignments? And I think
Yes, ma'am.
Zaid also did submit. Zaid, did you also submit? No, Magnetic Zaid didn't submit. The earlier one Zaid did. Samira, you have submitted the assignments. Just submit the
Yes,
last
ma'am.
one also. Alright, good, Samira. So I think only Samira has submitted from the new one.
Assignment 3 and 4, right?
The one which I have sent you, Khalid. I did send you 2 assignments, no, the recent ones. Those were the ones you were asking for, no? The recent assignments.
Yes.
That one.
Yeah, I did complete that.
Alright. So when you complete it, either send me it on the WhatsApp or upload it on the portal. If it's working, then you can upload it there. Otherwise, you can send me.
The time's up for the assignment on the portal.
Okay. You just submit it on the group. Submit it on the group if the time is up. There's a time limit to every assignment.
Yes, ma'am.
Okay. Khalid, uploaded. You have uploaded. You're saying. What, Khalid? You uploaded. I did it on the. I asked you. Just some words are missing. Okay, you've uploaded it on that same day only. All right. Those assignments which I sent you on the WhatsApp, you're talking about those magnetics, Khalid.
Yes, teacher. Wait, I'll check and send you again.
Just, yes. You can submit it on the group also. That's not an issue if anyone's app is not working. No. So all those, if the time limit is up and you're not able to upload it, submit it on the group. Sneha, your number has still not been added. Okay, Sneha. I just do one thing. I'll add you on the. Because all the updates and everything will be given on the group. If any changes occurs or timings issue. Okay, Khalid has submitted. Fine, Khalid. I'll see. Okay, good, Khalid. Others also, if you're not able to submit it on the app, no, your Learnivio app. How does the app work? Is it fine? Whenever I have seen the app mostly wasn't working that time. So is it working properly right now?
The server's a bit slow, but it's fine. It's fine.
It's fine now. So Khalid and Samaira, how did you find the level of assignments? Fine?
Yes, ma'am. It was fine.
It's fine.
See, the first case which we did was when the particle was parallel to the magnetic field, that was making an angle of 0 degree. Second one we did when the particle was making an angle of 180 degree with the magnetic field. Third one, this whole case we had seen when the particle was perpendicular to the magnetic field. So 3 cases completed. Last case, basically we are right now before moving on to what actually is Lorentz force. Lorentz force still has not been started. In Lorentz force, electric field is also included. So revise electric field once. Right now we are seeing the motion of the or the basically the path covered by the charged particle as soon as it is kept in magnetic field. So case 4 becomes if your angle is neither 0 degree nor it is 180 degree or nor even it is 90 degrees. If either 3 are given, that you can put it. If 3 are given, 0 degree, 180 degree, 90 degree, all the 3 are mentioned, then you can put it. Just a second. Yes. So yes, the last part is if your theta is not even 0 degree, not even 180 degree, and not even 90 degree. If all these 3 of the particles, these are not making either of all these angles. So if particle is at an angle, at a random angle, but the condition is that theta is not equal to 0 degree, theta is neither equal to 180 degree, nor it's equal to 90 degree. This is theta, I've made it as 5. This is theta. All the 3 conditions are there. Now this is the last case, last topic also for today and last case also. Now here basically in this you have the particle at a random angle. So it means instead of taking it either like this, that, I'm just taking it at a random angle. So let's say these are the magnetic field lines. Yes. This is the last topic. You can copy down it later also. This part you can see in the recording also. I'll end the class after this. This is a very short topic. You won't miss anything. You can leave. Go and pray. So let's say this will be the velocity. It's making an angle of theta. Charged particle is here going with this velocity. So right now we are not focusing on with the direction. Right now we're just calculating the magnitude. See, if I resolve the vectors, this part will be parallel. Just see resolution of vectors, those who have forgotten, with the angle with which the axis the angle is being made. We take it as which component, cos or sine?
Cos.
Cos, yes, we take it as cos. So this becomes what? This becomes V cos theta. And this is what? Parallel to magnetic field. So we'll write it as V parallel. And the other one, this is written as V sine theta. This is what? This is V perpendicular. All right, perpendicular to the magnetic field. These we have resolved the components. Now see how will be the motion of the particle. Here everything will be in, see, radius will also be mvv by qb, but V perpendicular will be included. Rest of the thing, time period also 2 pi m divided by qb is there. All these are valid for this. It is valid. But remember, velocity you have to particularly take it for the particular one, the perpendicular one. Now, what is the function of V perpendicular and V parallel? V parallel will basically, the velocity parallel will basically move the charged particle forward. And the function of V perpendicular is to move the particle upwards. So can you name anything, any motion from your knowledge or just by guessing, if the particle is moving forward also and upward also? Any idea, any guesses? I'll tell you, any guesses right now? See, basically this parallel component means this V parallel. This gives motion in a straight line. Fine, this gives motion in a straight line. V perpendicular gives upwards motion. So basically the particle has to go like this also, and it has to also cover a motion like this. Upward circular motion will be given. So what will happen? Not basically upward motion, it will give circular upward motion. Circular motion rather, I will say. It gives circular motion. That's appropriate. Gives circular motion. So a circular motion is also there. So forward also and circular also. Can anyone think what is this motion? Biology students can at least think of it.
Come again, sorry. What's the motion again?
Forward also it's moving, circular also it's moving. Can you name it? I'm asking, I haven't disclosed the name. No idea. See, forward, then a circular motion. Then parallel component will push forward. Then perpendicular will give circular. Forward, circular. This motion is known as helical. So basically in the last case, from the last case, you rarely get numericals. You get numericals, you have to use V perpendicular, but mostly this theory question comes to draw the path. So see what will happen. V, if this is the charged particle, V parallel will give it a forward motion. V perpendicular circle, V parallel forward, V perpendicular circle, and so on the helical motion will be given. So path will be what? Path will be combination of circle, path will be combination of circular motion and straight line. Therefore, it would be helical. This term is mentioned in NCERT, so this counts. Helical term is asked to write it. Yeah, so this is the last case, and we complete with the path, the whole path of the charged particle. That is done. Lorentz force particularly, we'll do it in the next class. In the next class, it will be completed. Note down this case as well. And when you are done, just text me done in the chat box. Write it so that I know. Then I'll stop the class. And others, Khalid, Samaira, and others. Salman, Sneha, you also tell when you are completed.
Done.